question here is asking us to determine the magnitude of the resultant force and the coordinate direction angles again of the same resultant force. So both of them, 293 and 294, exactly the same like each other, but the only thing is different, that is the magnitude of the forces applied. So we are going to solve one of them and the other exactly is going to be the same. So asking us to determine the magnitude of the resultant force applied on this pulley in here. We know that there are two forces applied on the pulley at specific locations. Therefore, to find the magnitude of the resultant force, we need to find the resultant force itself first. And we know that the resultant force is going to equal, resultant force in this case, Fr, equal to FAB plus FAC. Now we need to find each force of those two forces in there and add them together. For FAB, that is equal to FB itself, the force that is being given or applied, multiplied by the unit vector B. So FB is known, unit vector is unknown. Finding the unit vector UB equal to, the unit vector UB is equal to the position vector of AB divided by the magnitude of that position vector, position vector RAB. Now finding the position vector RAB first, RAB equal, so the coordinates of RAB, when we look at this diagram in here, it is 2 meters on the positive x-axis, 3 meters on the negative y-axis, and 6 meters on the negative z-axis. Pay attention to that. Negative because the forces here are pulling downwards, and since the force is pulling downwards, the impact is on the negative z-axis and not positive z-axis. Therefore, what we're going to have in here, we're having 2i plus, minus 3j minus 6, okay? And to find the magnitude of this position vector in here, we take the square root of the sum of all of these coordinates, plus negative 3 square plus negative 6 all square. When you plug that into your calculator, that should equal to 7 meters. Now since we found the position vector and the magnitude of the position vector, easily we can get the unit vector B, and that is equal to over the magnitude, which is 7i, negative 3 divided by 7j, negative 6 divided by 7k. This is the magnitude of the unit vector B. Now easily we can find FAB, and that is equal to the forces being given in there, which is equal to 560 Newton. That is multiplied by multiplied by the unit vector B, 2 over 7i minus 3 over 7j minus 6 over 7k. Now plug that into your calculator and should equal 260i minus 240j minus 840k. And again, this is the first force we are solving for. Now we're going to find FAC itself equal to FC multiplied by the unit vector C. Now finding the unit vector C itself, which is equal to the position vector RAC divided by the magnitude of that position vector RAC. So now for finding the position vector RAC, that equal to, when we go back to the question here and we look at the position, our positions for this vector in there, we can see that 2 meters on the positive x-axis, 3 meters on the positive x-axis, 2 meters on the positive y-axis, and again negative 6 meters on the negative z-axis. So we are just going to write this down for the RAC, which is 3i minus plus 2j minus 6k. Now finding the magnitude of RAC equal to the square root of these coordinates in there. All of that should result into, again, 7 meters. Now find a new AC, which is equal to 3 over 7I plus 2 over 7J minus 6 over 7K. Finding FAC, which is equal to FC itself, which is 700 Newton, multiplied by the UC, 3 over 7I, 2 over 7J minus 6 over 7K. Now we got both FAB and FAC. We are going to add them together. The way we add them together, we add the I component together, J component together, K component together. So we know that FR equal to FAC plus FAB plus FAC. So this equal, once you add both of them together, that should equal to 460I plus minus 40J minus 1080K. Of course, this force here in Newton. Don't forget to put your units, guys, in there. So we found FR. Now we're going to find the magnitude of FR itself, which is the square root of these coordinates in there, 460I square plus negative 40 square plus negative 1080 square. When you plug all of that into your calculator, you should get something like 1174.56 Newton, which is equal 1.17 kilo Newton. Now we found the magnitude of the resultant force. We are going to find the coordinate angles, the coordinate direction angles in this case, which is alpha equal to inverse, of course, of the resultant force on the x direction divided by the magnitude of the resultant force itself, and in this case equal to the inverse, of course, still here, 460 divided by 1174.56, and that should equal to 66.9 degrees. Again, beta equal to the inverse, of course, of FR of the resultant force on the y direction divided by the magnitude of the resultant force itself, and all of that again should equal to negative 40 in this case divided by 117.56. All of this should result into, in this case, 92 degrees. Finally, gamma should equal to the inverse, of course, again, of the resultant force on the z direction divided by the magnitude of the resultant force itself, and that should equal to, in this case, negative 1080 divided by 1174.56. all of that should equal 157 degrees. If you want to draw your resultant force, it's okay, you can, but since it's not required, then I'm not going to do it. So this is the way you solve the questions, guys. See you in the next video for more questions like this.